Okay, so this is going to be the second day in 5.3. If I didn't mention it yesterday, I meant to. Yesterday is much more computational, right? We're actually working with numbers, we're foiling, we're doing like terms, all that stuff. Today is a lot more conceptual, okay? So once we're done, you're going to realize you didn't take a whole lot of notes today, okay? And you're not going to, all right? So you better be paying attention, because that's really how this is going to make sense, okay? It's honestly just through watching. There's not going to be a whole lot to write down, okay? Basically what we're going to do today is we're going to look at the graphs of polynomial functions, okay? And there are different things that we're going to look at within those graphs. And we're going to pick some similarities and focus on those, okay? So to do this, I'm going to go over here. All right. Let me think. Let's start with the basic one. Let's start with x squared. Okay, let me switch this into projector mode so y'all can see it.
You want us to put these in our calculator?
You don't need to. Nope, just watch, okay? Just watch me, all right? Tell me some things about this graph. Like, you know, the direction it's pointing, arrows, end behaviors, touching the, okay?
Passes the line test.
Passes the line, vertical line test, I like that. Okay? What else? Which direction is it pointing? Up. Okay, and specifically, they're both pointing up, all right, on an x squared function. All right, because see how it's red here and see? Okay, see that? That's what's graphed in red. Look at that. Cute and color not coordinated. See that? It's adorable. Okay, everybody good with that? All right, that's your basic x squared function. All right? I'm going to do this now, okay? Minus 2. What happened? It dropped 2. Okay, Mr. Garcia nailed it. Dropped 2 spots. Okay? Didn't change anything though about the way it points or anything like that, right? Okay? So, I'm going to then take this same function, but I'm going to make it negative. Okay, let me pull it down just a little bit so it's more centered. All right, there we go. So what's different from the blue to the red? Pusa? It's going down. Anything else? I mean, okay, obviously you're going to have different numbers in your points, but just visually, anything else different? No, there's nothing else different. The only difference is it points down. Okay? Everybody good with that? Okay, I'm going to turn off the blue. Oop, goodbye. I'm going to pick a new one. Let's go x. Let's go a little big. Let's go big or go home. Let's go x to the 6th. All right, I'm going to make this one ugly, so bear with me here. Minus x, 5x to the 5th. Plus 4x, or 42. Yeah, 4x to the 4th. I want to make sure this works out nice. Minus 3x to the 3rd. Plus 2x to the 2nd. Minus 2x. Yeah, that was good. Plus 1. Okay. On purpose. Okay? On purpose. All right? An ugly, ugly, ugly fraction. Okay? I'm going to turn the red off for now so we can focus on the green. Okay? And I'm going to zoom out. Hopefully not too obnoxious, but I figured it would be obnoxious, yeah. Okay? So let me make this just a little smaller then. Okay? Those of you watching the video, this is what's called live presentations. Let's make it x to the 4th plus 2x to the 3rd minus 3. Let's leave it like that. Okay? Still nutty. All right? But there it is. Okay? What do you notice about it? What about the ends of it? The ends. Like over here and over here. They're both pointing up. Okay? Which is similar to what? Which graph? From prior, the red or the blue? The red. The red. So I'm going to turn it back on. Okay? If you notice, the red and the green are both pointing up. Okay, let me move these side by side now. I think I can do that like this. Yep. Okay, now move, instead of the graphs, look at the functions. Specifically, look at the degrees. Okay, look at the degrees. Remember from yesterday, what's a degree?
It's the exponent, biggest exponent.
Biggest exponent, okay? Both of these degrees on the red and the green are what? Even. They're both even. Okay? I'm going to turn the blue graph back on because this degree is what?
Negative.
Degree? Even. And its arrows are pointing in the together. They're going the same way. Okay? The blue ones are, right? I'm going to make another one. Let's go x to the 6th. Nice and orange. Make another one. X to the 8th. That one's, oh, I got to actually put x to the 8th. Purple. Cute. X to the 10th. Black. Nice. Okay? All three of these, the orange, the purple, and the black, they're all doing what? Going up, and both of them are, right? Just like the other two. Just like x squared, x to the 4th. And all 5 of these functions, all 5 of their degrees are what? Even. Coincidence?
I think not.
Exactly. If you have even degree, the ends will point the same direction. Okay? Now, let's turn this blue one back on. Boop. Why is everybody else pointing up and blue pointing down? Because what's negative?
The base.
Word from yesterday.
The LC.
There you go. The LC, which stands for? The leading coefficient. Good.
I
Okay?
just wrote LC on the page.
That's fine. Okay, just as long as you know what it is. Okay? The leading coefficient is negative. All right? So, even degrees, negative, positive leading coefficients point same direction. That direction is up. Negative leading coefficients with even degrees point down. Watch this. Boop. See how I flip my orange graph now? It's pointing down. I know there's a lot of craziness going on. Colorful, you know.
I have a question.
What's up?
So what happens if it's like x to the 3rd?
Ooh, I guess that's what we're going to do next. All right. Everybody good so far on that? Okay. For time's sake, we're actually going to do that next. Okay. So let me. This is probably faster just to clear them all out. Okay. So let's go with what Pusa said. Let's look at x to the 3rd graph. There it is.
Oh my.
A nice, calm, beautiful curve. Okay. So what do you notice about it? What's different from it as compared to the x squared graph?
Looks like a roller coaster.
Looks like a roller coaster. I like that. Okay. It actually legit looks like a roller coaster a little bit. Okay. What else specifically about the ends? Let me throw the x squared up again.
One's pointing up and the other's pointing down.
One's pointing up. Okay, turn x squared off. One's pointing up. One's pointing down. Okay. Whereas on x squared and 4th and 6th, they were all pointing in the
Both up.
well. What about negative x
Same
squared?
direction.
Same direction. Okay. They're both pointing in the same direction. X to the 3rd is pointing in
Different direction.
different. You do an O word for different.
Opposite.
Opposite directions. There you go. Think that's going to be true when I put an x to the 5th?
Probably.
Yeah. X to the 7th? Yeah. Ooh, green. Cute. X to the 9th? Yep. You get it?
Yeah.
Okay.
But like, does it look like that because it's an odd?
Mm-hmm. Exactly. 'Cause since the odd degrees, right? These are all odd degrees. They all go in opposite directions. I want to do one thing to the blue graph. Ready?
Pink.
Now, what did it do?
Flip.
It flipped, okay? Now, the hardest part of this is going to be that with your odds, okay? Which way is it going to be whenever you're going up, whenever you're going down? So I'm going to delete all but these two. I'm going to hopefully make this so that they're a little further apart. So let's go -2 there, good. Let's go +1 here, good. Okay? Zoom out just once time. All right, now, look at your red and look at your blue. How do you read a book? How do you read a graph? Left to right. Okay? Left to right. So from left to right, what's the red graph doing? Going up. Okay? From left to right, what's the blue graph doing? Going down. Okay? Yelling timber, right? Thank you. I'm here all week. The red graph, the red function, if you look over here, it's odd degree. What's its leading coefficient? 1, which is a positive. And on the graph, it's increasing. Okay? The blue graph is decreasing, and its leading coefficient is negative. Those 4 qualities are true in all situations. Okay? So, to summarize all of these, the book made this slide. Okay? Now, there are some things you don't need up here. Okay? For example, end behavior, we're going to do something completely different than what's up there. Okay? So you don't need any end behaviors, nor do you need domain and ranges. Okay? We're going to do end behavior eventually, just not the way they're doing it here. Okay? If what you need to write is the degree, let me highlight with green here, the degree, the leading coefficient, and the graph itself. Okay? On all 4. Okay, so write down all 4 of these, kind of make a quick little picture of the graphs. All right, this is what I just explained to you guys. This is everything we just did. Okay, because if you look on this, on the first one here, the degree is even, leading coefficient's positive. Look at the graph, point in the same direction, and that direction is up. Okay, so this goes, and that goes for every single polynomial that's going to have an even degree with a positive leading coefficient. It's going to point up both ways. Every single degree of odd numbers in a positive leading coefficient is going to be increasing from left to right. Okay? There might be some funky stuff in the middle, okay, where it actually does, like Pusa said, look like a roller coaster. Okay? For example, you could have like, ooh, like this. Okay? Technically, you'd have to go, well, Mr. Mormon, it's increasing for a little bit, then it starts increasing, then it starts increasing some more and more and more. I only care about the ends, okay? In big picture, what are you doing? I don't really care about this little dip. I want the big picture, which is increasing, okay? Now let's talk about the zeros, okay? So, your zeros of a graph. Your zeros of a graph are where you cross the x-axis. Okay? That's actually old news. That's chapter 4. Okay. The zeros of the graph are where you cross the x-axis. What you need to, what's new now is the zero. This kind of, it's not called a theorem, but it could be. If you have an odd function, and let's start there with the odds. Okay? If you have an odd function, you will have an odd number of real zeros. If you have an even function, you will have an even number of real zeros or no real zeros at all, as per example of the heart attack that's happening right here. Okay? It doesn't touch the x-axis ever, does it?
Oh.
Alright, so that's what makes no zeros. Okay? That's how many times you touch the x-axis. Alright?
Thank you for being here all week.
Yes. Okay. Now, because the odds have to have an odd number is because, or the reason the odds have to have an odd number is because you have to start on the top and end on the bottom, or start on the bottom and end on the top. Okay? Which means at some point, To do that, you got to cross the x-axis. Okay?
So that's one.
This is 1. Yep. That's exactly right. Alright, there's no bridges across the x-axis where you can go, whoop, I'm over it, yay, and not touch it at all. You had to touch the x-axis. Okay? Okay, so you are going to basically be asked 3 different questions. The degree, leading coefficient, and the number of real zeros. Huh? That looks like degree. Agree. What's up, agree? Degree. There we go. All right. So for 4A, we got A. Can you see that? Not really. Let's try the red. A, B, C. For B, we have A, B, C. Okay. So 4A is graph. Now the key part is remembering which words go with which question. Okay? You basically have 4 words to know. Odd, even, positive, negative. Your job is to remember whenever I ask for the degree, what am I talking about? And as long as you know the definition to a degree, it should help you. Okay? Because the degree is what? On a function. It's the biggest exponent. Mr. Pusa, can that exponent be negative?
Yes.
Try again. No. Otherwise, if it is negative, you don't have a polynomial. Okay? So if I ask you degree, and you think to yourself, biggest exponent, okay, it's got to be bigger than 0, and that means they're all positive. I'm not asking you just to write positive there. All right? Degree, I'm looking for either odd or even. Evens point same direction, odds point opposite direction. So 4A's degree is going to be what? Odd. Okay. Opposite directions means odd degree. Okay. Leading coefficient, probably the most challenging one of the group. Big picture wise, are you increasing or decreasing? Decreasing. Okay. Read from left to right, right? We start up here, woo, go down, come up a little bit, but in the end, we are going down, down, down. Since you're decreasing, that means that your leading coefficient is negative.
So like in the book,
I'll get there. Okay. Hang tight.
and behavior is degree.
I'll get there. Hold up. Okay. See, number of real zeros. How many times across the x-axis?
3.
That's it. Okay. 3. That's it.
3.
Right there. Right there. And right there. Okay. So let's go to B now. What's its degree? Even. Why even, Sydney?
Because the ends point the same direction.
Ends point same direction, okay? Ends point same direction, so it makes it even. Now, that direction is down, which tells you the lead coefficient is negative. Good. And then across the x-axis, Xavier, how many times? 2. Sorry, it's behind the logo, but 2. Okay?
It doesn't matter if it crosses the line.
No, y means nothing to you for this. Okay, y-axis means nothing. All right, so your homework is going to be page 326 through 327 is what it's going to eventually be. 35 through 40, 47 through 50. Okay, before I finish, let me show you something. Okay, just so we're all on the same page with this. Okay? The directions in the book are going to be just a little bit different than what I want you to do. Okay? I want you to do it in the same order that I did it. Okay? So, I'm going to change these directions a little bit, okay? This is gone. This B becomes your A, which is determined that whether it represents an odd or even. Okay? So do that first, because that's the easiest way to do it. Figure out odd, even. Okay? Your B, I'm going to put it over here on the side. Your B is talk about the leading coefficient, whether it's positive or negative. Okay? C, state the number of real zeros. That stays. Okay? Is everybody clear on that set? Everybody good? Okay.